Hey, sixth grade science, I know you guys are tuning into YouTube. You got a great teacher. And I'm Mr. McCall, eighth grade teacher that's upstairs, but I'm American history. So I wrote this, I didn't write this song, somebody else wrote it in 1972. It's called Rocket Man, but I changed it to Science Man for Mr. Scheuch, so it's my ode to Mr. Scheuch. It goes like this. All this science, yeah, I don't understand. It's just his job 5 days a week. Science man, he's a science man. And I think it's gonna be a long, long time till school brings us around again. I know he's still the teacher used to be. Oh yeah, yeah, yeah. He's a science man. Science man. Doing his thing on YouTube, yeah. Science man is an inspiration for me, man. 'Cause he's a science man.
Is this thing on? Is this thing on?
That's to you, Mr. Scheuch.
Is this thing on, guys? Is it? Oh, hey, everybody. It's Friday. Woohoo! Sorry, Mr. McCall there. He wanted me to put that on. He wrote a little song this morning. Well, he played a little song this morning and sent it to me. He's a social studies guy. He's really not into science so much, but he's trying. He's trying. But he's singing a song based on a song called Rocket Man by Elton John. And you know what? Today, we're going to talk about rockets. All right, we're going to talk about rockets a little bit today. Got a couple other things on the agenda. Hope everybody's doing well on this Friday. Another nice day in the 60s outside today. Looks like I'm going to be getting outside right after this. You know, going to clean up the yard a little bit, light a fire, hang out with the fam for a little bit this evening. Good to see everybody back. All right. Wow, look at that. We got some people knowing who Mr. McCall is. Awesome. Really cool stuff. Nice. All right, so today, let's take a look at what we got today. That was Mr. McCall, by the way, for those of you asking if that was Mr. McCall or not. Sure was. I took a couple of your questions from yesterday, but then I actually decided to go off script a little bit today and do something related to something I talked about 2 days ago, which was Newton's third law of motion. Every object or every action has an equal and opposite reaction. That's what we're going to get into in just a little bit. So today, one of the questions somebody asked me yesterday was, what is the animal or insect or living thing that could survive the harshest conditions on the earth? Okay, it could survive the hardest conditions on the earth. So I told you yesterday it was a ptarmigan, and I misspoke. It's not called a ptarmigan. A ptarmigan's a type of bird, all right, but it does kind of sound the same. It's called a tardigrade. A tardigrade, otherwise known as a water bear. Okay, a water bear, and this is what they look like. Let me show you what they look like so you can actually see my screen here. So, let me get this out of the way, as usual. Make myself smaller. And now, I'll show you a picture of what a tardigrade looks like. That's a tardigrade, all right? That thing is called a water bear. And these things are unbelievably resilient to changes in their environment. They're only about a millimeter large. A millimeter. That's like that. That's how big they are. You need a microscope to really take a look at them. But they look like little bears, don't they? Well, these guys can survive pretty much anywhere. Anywhere you think that they wouldn't be able to survive, they can. Surviving a nuclear blast and all that radiation, no problem. Okay, they can survive pressure 6 times that of the highest pressure that's found underneath the oceans. Okay, from all that water on them, 6 times that. They can survive that. They can survive in cold. They can survive in hot. They can survive radiation. Okay, they can survive without actually being living for a number of days or weeks. They curl themselves up into a little ball, and they can survive that way, and all they need to do is get back in water for about an hour or so, and they become fully functional again. This little mouthpiece right here, that can actually extend out to eat some of its little prey that it likes to go after. I do have some information about tardigans here that they're also called moss piglets, which is an interesting thing. Okay? They actually live in water. They live at the bottoms of lakes and ponds and the muds and things like that. All right? What else? They can go, they can survive in space. They've survived in space before. We've brought them into space with us. So these guys are pretty resilient little things. Let me see what else we got here about tardigrades. Tardigrades. They were first found in 1773. All right. But these things can survive. In cold temperatures, they form into a special, they're called a tun, is when they curl up. Okay. And it prevents, in cold, they prevent the growth of ice on themselves with their bodies. It's called cryptobiosis. That's and the longest they've known a tardigrade to go into cryptobiosis is 30 years. 30 years. It looked like it was just dead. Put it in water, comes back to life in an hour or so. Okay, so that right there is the creature on Earth that can stand the harshest conditions that you could possibly throw at it. That's the one right there that can survive it. Okay, that's the one that can survive it. They are unbelievably strong. Now, let me take a look at everybody's got. Can we play Kahoot even though it's delayed? How about we try to play Kahoot on Monday? On Monday, I will try to play Kahoot, and we'll do it a way where I challenge you. We won't play live time, but you guys can play while I'm talking. Okay? That's gross. You think it looks kind of gross? I think they look kind of cute. All right? Is it true that there is 1 in a quadrillion chance that if you poke a wall with your finger will go through it? Whoa, I don't know, Sophie. I haven't heard that one yet. I don't know. I'll take a look at that. Oh, bones and muscles. That's right. That was the other thing. I'm going to do that on Monday. All right, let me write that down. I believe that's Colin. So Colin wants to know about bones and muscles and how that whole thing works. It's a really good thing to know since you are, a living, breathing, walking human being. So let me put that in here for Monday's show. Bones and muscles. Okay, now, for today, the next thing I want to talk about, and you're going to be wondering, how in the world is... I thought you said we were talking about rockets. We are. This is what I want to talk to you about next, though. This is a wonderful insect, all right? We all know it's a dragonfly, okay? Dragonflies, and the reason I picked dragonflies today, one is because it relates to rockets, which we're going to get to in a little bit, and two, they're going to be starting to come out soon here. We're going to start to be seeing dragonflies out in the river. So, by the way, this is a dragonfly. You can tell it's a dragonfly because it's got these 2 different wing segments right here. But when it lands, notice those wing segments are flat like this. Okay, there is another type of fly called a damselfly that looks like dragonflies, but when they land, their wings are up like this. So dragonflies' wings when they land are flat. Damselfly wings are up like this. Now, when you see a dragonfly like this, which is pretty much every time we see a dragonfly, when you see a dragonfly like this, sadly for the dragonfly, it's at the end of its life. Okay, it's been around for a couple years, but when you see them like this, it's at the end of the life of the dragonfly. Talk a little bit about the life cycle of a dragonfly, and then we'll see how this relates to rockets. So here we go. The life cycle of a dragonfly. Dragonflies, like all insects, come out of eggs, okay? And then they hatch, and what they form is called a dragonfly nymph. That's this guy right here. And I'm going to talk about the dragonfly nymph in a little bit because this is what's going to lead us into rockets. How in the world can that lead us to rockets? Well, we'll get there in a second. Dragonfly nymph. This nymph can be under the water. Dragonfly nymphs live at the bottom of ponds and rivers and streams and lakes. Okay, and they live at the very bottom for years. For years they're like this on the bottom. Okay, not just days. Well, when they get old enough and they grow their wings underneath their exoskeleton, they crawl up onto a leaf or a stem, and they go through what's called metamorphosis. Metamorphosis, as we know, is when when a creature goes from one form to another. Well, they'll hatch out of their exoskeleton and they'll become a full-fledged dragonfly. All right. When we see them like this, they have less than a year to live. Okay, so they're really at the end of their lives when we see dragonflies flying around like this. They're spectacular flyers. If you ever just sit and watch a dragonfly fly, it's really, really cool. They can fly forward, backwards, up, down, and they can actually, without turning their body, they can go straight right. I guess that would be left for you. I can't tell if I'm backwards or not. They can go side to side. Okay, so they can fly without turning their body. It's up, down, left, right. Okay, and they can go forward and backwards. So they can go 6 different directions without even moving their body. All right. Now, this is the part of the dragonfly that I want to concentrate on today. Okay, this is the dragonfly nymph. It's called a nymph. Now, this is the funny part. They live underwater, which means they have to be able to pull oxygen out of the water to breathe, like a fish or any other aquatic creature that lives under the water. They have to have gills. All right. But if you look at this, it's not a fish. It's actually an insect. Dragonflies are insects. And you can tell because it's got 3 body parts. It's got the head, the thorax, and the abdomen. Okay. And it has 6 legs. Every insect has 6 legs. If it doesn't have 6 legs, it's not an insect. So spiders are not insects. They have 8 legs. Okay. Now, this part right here. This is the part we're going to concentrate on today. The backside. The backside of the Dragonfly Nymph. Now, well, if they have to have gills for living and breathing under the water, normally you would think the gills are up here on the head, right? Like on a fish. The gills are tucked back up under here, underneath the jaw of the fish. Not where they are in a Dragonfly Nymph. Go ahead. Guess. Where do you think they are? Think about it. Where do you think the gills of a Dragonfly Nymph might be? They're not on the head. Aha. All right. Well, here's where they are. The gills on a Dragonfly Nymph are in its butt. You heard me correctly. I'm not lying. The gills for a dragonfly are in the dragonfly's butt. So here's what they have to do. In order for them to breathe, and this is going to sound so weird. You know how we have to breathe air in, blow air out? Well, they got to do that too, but with water. We breathe air into our lungs and out of our lungs. Well, I just told you where the gills on a dragonfly are. In the dragonfly's butt. Well, if we have to breathe air in and out of our lungs to breathe, where do you think they have to breathe water? Yep, that's right. In and out of their butt. That's how they breathe. Now, still, how in the world can this guy right here be related to rockets? Well, here's the thing. Dragonfly nymphs on the bottom of a creek or a stream or a river or a pond or a lake, they are competing for food with all the other creatures around them. Okay, so they have to be able to get to their food faster than the other creatures. Well, you would think that just a little tiny insect, because the dragonfly larvae is only about a couple inches long at the most. These little creatures with 6 legs walking around on the bottom of a stream probably can't walk very fast up and over the rocks and the pebbles and everything that's in the bottom of the stream. So they had to adapt to their environment, and they had to come up with some way to get to food faster, called an adaptation. So what they did, they evolved this adaptation over time. Remember I said they have to bring air in and out, or water in and out of their butt to breathe? Well, here's the thing. Think about if they left the air or the water out of their backside fast enough. If they push the air or the water, I keep saying air, it's water. When they push water that way out of their butt, we talked about Newton's 3 laws the other day, right? So for every action, there's an equal and opposite reaction. So if they push water that way out of their butt, that means the dragonfly nymph is going to go that way through the water. And the faster they push it out, equal and opposite reaction, the faster they're going to fly forward. It's crazy. And these little guys right here can go up to almost 40 miles an hour underwater just by squirting water out of their butt. Okay? And that process right there, that's the exact same process that makes a rocket launch up into the sky. All right, sounds kind of funny and weird, I know. But that's the process that makes a rocket launch up into the sky. So, today's lesson, today's little experiment that I want you guys to talk about and think about and try to do at home is about rockets. We're going to make some rockets today. I'm going to show you how to do it. I'm going to show you how to make some rockets. And it's really fun. It's cool because you can there's all kinds of physics stuff involved in here. Now, physics isn't really till you get to 8th grade, but that's okay. All right? You get a little introduced to it right now. So, let's talk about rockets. All right? Let's talk about some rockets. So, if we go back here to my screen that I had before, all right, and we look at a rocket launch. Now, here, this is the space shuttle. The space shuttle's right here. The rocket's underneath it. Okay? The space shuttle is not a rocket. It is a space shuttle. This is the rocket, the boosters that power the space shuttle up in the air. So here's what happens. These boosters on this rocket have, combustion going inside of them. There's things exploding, the fuel's exploding, and it's shooting out the bottom of the rocket. Well, by shooting out the bottom of the rocket, that makes the rocket top go up. So the faster the flames come out the bottom, the faster the rocket goes up in the air because of Newton's 3rd law of motion. Every action is an equal and opposite reaction. So here is what I would like you guys to do if you want to. I know some of you are still working on some of the other projects I put out there for extra credit or for enrichment. Fine, no problem. Do it if you want to. Don't do it. It's another little competition thing you can do with your friends and your family. It's kind of fun. So let me show you, first of all, on Schoology. Nope, that's not what I wanted. This is what I wanted. On Schoology in today's folder, I put two things. One, I put the instructions for what I'm going to show you right now. All right, I'm going to show you how to do it. And then those are the instructions for if you want to do it on your own later. And then if you want to submit to me with some ideas and some things you learned, there's the submission right there. So the first thing is the Balloon Rockets PDF. This is the instructions of what I'm going to show you how to do right here. You guys are going to make your own balloon rockets. And we're going to zoom them across your house. It's really fun. And it's the exact same way that a Dragonfly Nymph moves across the bottom of a creek or a pond. So here is the PDF. Now, remember, if you're turning it in for extra credit or you want some enrichment, fill out the questions. Do the best you can on it. All right, yeah, it's fun, but I also want to know what you learned. I am a science teacher. You got to learn something. So in here, you're going to see the instructions. Now, it's taking forever to load because it's a rather large PDF, and my computer is not the fastest thing in the world. All right, so let's get this lesson all booted up here, and we'll see what happens. It doesn't take very long to do. Things you're going to need. You're going to need a balloon. You're going to need a straw. You're going to need some string. You're going to need some things like permanent markers, some cargo to put onto your rocket, all right? Anything you want to in the materials list there, just go ahead and take a look through there. And then here's what we're going to do. We're actually going to create a rocket, and we're going to fire it off with a balloon rocket, and you're going to be able to measure the speed of that rocket in feet per second. And you can calculate that in miles per hour a little bit later if you want to. So let me show you how to do this. Let me get back to my screen here. So what I'm going to do is I'm going to actually take off my green screen. I'm going to use the area behind me here to show you exactly how to set this up. So I'm going to take this off, take that off, and I'm going to take this off right here, and take that off, and then, sorry, I have to fix myself up here so you guys can see what I'm talking about. You got to be able to see behind me. Look at this. Now you're in the production part of my my video. You can see all my secrets. All right, there we go. Now you can see behind me. Perfect. All right, now let me show you how to do what we're going to do here. I'm going to make myself big on your screen so you can see the whole thing that's going on. So let me show you. Welcome to my studio, by the way. It's my my guest bedroom. I told you that yesterday. So you're in the house here. All right, so let me show you what we're going to need. In order to do this, you guys are going to need a straw. You're going to need a balloon. And you're going to need some string. Okay? And you're also going to need the stopwatch and the calculator on your phone. So, I'm going to get my stopwatch ready here first. So here's your stopwatch. Whoop, I guess you can't see it. Stopwatch on your phone, balloon, string. Here's what you're going to do. I'm going to show you how I set myself up here in my little studio. Now, take your string. I have my string tied to one side of my room. All right? Now what I'm going to do is I'm going to take the other side of my string in just a second, and I'm going to put my, you got to make sure you put your straw on your string first or it's not going to work out for you. You got to take your straw, put it on your string, okay? Get it threaded all the way through there. Now you can tie your string to things in your house. I'm going to use some thumbtacks because, it's my guest bedroom and I'll just redo the wall later. But I wouldn't suggest putting nails or thumbtacks in your walls of your house. Tie it to a couple things in your room. All right, so now I have my string. I have my straw on my string. And what I'm going to do now is I'm just going to tie this to the other side of the wall. So now I have a very, very straight track for my balloon to go on. Okay, it goes from one side of the room to the other. Now, the next thing I have to do, and this is important because if you're going to find speed, there's two things you got to know. You got to know distance, and you have to know time. So how far is it going, and how long did it take? So what I'm going to do is I'm going to grab my tape measure here, and I'm going to measure from my one side of my string to the other, and I get exactly 5 feet. It's exactly 5 feet. So I'm going to remember that. 5 feet. Now, I have to blow up my balloon. Now, you guys can do this as any variable you want. I have a rather large balloon, okay? You can use small balloons. You can use bigger balloons. You can change the amount of air pressure you put inside the balloon. I want you to be able to try to see which setup makes your balloon rocket travel the fastest. Now, once you get your balloon all blown up, then you're going to take your string and some tape, and you're going to tape the balloon to your straw. I suggest using 2 pieces of tape, one towards the front of your balloon and one towards the back of your balloon like this. Okay, now comes the important part. Do not let your balloon go yet. You're going to use your stopwatch on your phone, and you are going to time the time it takes your balloon to go from one end of your string to the other. Okay? Let's see how it goes. Ready? Go. Whew. That was 0.25, so 25 hundredths of 1 second. That thing was cruising. All right? Now, if I had a longer room with a longer string, it would go a lot further. I suggest setting up a longer course than I did. I'm just kind of confined here to my little tiny spot in my room. I suggest setting up a long string. Why not? Why not? Set up a long string. Get that balloon zooming across your living room. Now, in order to find my speed of that balloon, how fast did my rocket just go? I'm going to take my distance, which was 5 feet, and I'm going to divide it by my time, which was 0.25 seconds. So I take my calculator on my phone, and I do 5 feet divided by 0.25 seconds, and I get 20, which means my rocket balloon was traveling at 20 feet per second. Think about that, 20 feet per second. That's like 2 basketball hoops stacked on top of each other. My rocket balloon traveled 20 feet per second. So in 1 second, it would have covered the height of 2 basketball hoops stacked on top of each other. That's pretty awesome. That's pretty cool. So when you do your balloon rockets, see how fast you can get them to go. Calculate your speed, distance divided by time, and if you forget that, equation, it's in the document I put on Schoology for you. All right, it's in that document. In here, you will find the equation for speed. It's down here. Where is it? There, here. Speed equals distance divided by time. And then in some of the questions down here, you'll be able to, this is the directions here. It talks about putting cargo on there. How does weight affect your balloon rocket? There's so many different things you can do to your balloon rocket to make it different. Okay? It's a lot of fun. So today's lesson, balloon rockets, Newton's third law. When I put this thing, when I let it go, we had the air coming out the back of the balloon and the balloon going forward. That's Newton's third law. Every action is an equal and opposite reaction. All right? So, that was kind of cool. I thought that was kind of fun. All right, so that was my lesson for today. It's Friday. Have a good weekend, guys. Rocket science is awesome. You are right. And if you want to listen to Elton John, Rocket Man, while you're doing it, highly suggested. Great song. That was the song that Mr. McCall was playing earlier in the broadcast. All right. Now, let me just see what's going on here with. I hope you guys are able to see all that. Why can't a frog jump backwards? Oh, man, Torrin. Another question by Torrin. That's awesome. I'm going to go back through the questions like I always do. All right, I'm going to go back through the questions like I always do and see what I can pull out. Why can't frogs jump backwards? There's got to be a joke in there somewhere, right? Somebody made up a joke about frogs jumping backwards, I'm sure. All right, listen, everybody. Have a great weekend. All right, hopefully next week we'll get a little bit more direction as to where we're going with school and things like that, but we know we're not in next week. I'll be back here on Monday. I got 5 days next week. We'll keep doing the same thing. I'm loving reading your posts that you've been putting in and your creative writing and your stories and things like that. So, keep it up. All right, guys. Have a great weekend. See ya.